Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss properties of magnetic field, that is divergence and curl of magnetic field and its significance. Let's begin. Properties of magnetic field B vector. Property number 1, divergence of magnetic field. Means grad dot B is equal to 0. Divergence of magnetic field. We have to prove. According to Gauss law in magnetostatic, the total magnetic flux associated with a closed surface is always 0. Magnetic flux associated with a closed surface is always 0. Mathematically we write it, magnetic flux phi B is equal to closed surface integration B dot ds is equal to 0. That is equation number 1. Again, from Gauss divergence theorem, the surface integral can be changed to the volume integral. According to Gauss divergence theorem, we have the surface integral B dot ds is changed to the volume integral grad dot B dV. Equation number 2. Now comparing these two equations, here the closed surface integration of B dot ds is equal to 0. Here the closed surface integration of B dot ds is equal to integration over that volume grad dot B. Now comparing equation 1 and 2, we have volume integration grad dot B dV is equal to 0. That integral is equal to 0. That indicates the divergence of that vector field will be 0. Grad dot B is equal to 0. So the divergence of magnetic field will be 0. Again, in electrostatics, we have grad dot E is equal to rho divided by epsilon naught, where rho is the volume charge density that is Gauss law in differential form. This is the Gauss law. In differential form. From this law, we conclude that for the production of electric field, the charge is responsible, means monopole of charge is possible. But here the divergence of that magnetic field is equal to 0, that indicates mono charge or monopole of magnet is not possible. So the physical significance of that expression graded B is equal to 0. There are no magnetic charges that is independent of magnetic monopoles. There is no magnetic charge, means magnetic monopole do not exist. Property number 2, magnetic field lines neither have ending or nor beginning, that is these lines are continuous. For charge, the electric field lines are inwards. Here the electric field lines towards that electric charge. The field lines here outward. In this case, the field lines are inward. But in case of magnetic field, look here, a current carrying wire produces magnetic field, and these field lines are continuous. Here the magnetic field lines neither have ending or beginning, but these field lines are continuous. Next property, the number of magnetic field lines entering any closed surface are equal to that of lines coming into this. The number of magnetic field lines entering any closed surface is equal to the number of lines coming out. It. If the number of magnetic field lines are entering is 5, then the number of magnetic lines out are also 5. These two are same. That indicates the pole strength of the magnet is same. Means north pole strength and south pole strength are equal. This explain the pole strength is equal in that magnet. Property number 4, the magnetic flux through a closed surface does not depend on the size and location of closed surface. That point refers the flow of conservation of magnetic flux. This referred the flow of conservation of magnetic flux. If there are some charges and we take the surface here S1, according to Gauss law, the electric flux associated to that of surface S1, again we take another surface S2. So the magnetic flux, the electric flux are different. If the number of charge enclosed within that of surface is increased, then accordingly the electric flux increased. But in case of magnetic field lines, the magnetic field lines associated with that of closed surface is independent of that of size of that of surface and its location. Here the magnetic flux is always 0, as the magnetic field lines are continuous. These are some basic properties of that equation grad dot B is equal to 0. Next property of magnetic field, that is curl of magnetic field. Property number 2, curl of magnetic field. that is grad cross B is equal to mu naught into J. Let we prove that equation. According to Ampere's circuital law, the line integral of magnetic field induction B along a closed path in vacuum is equal to mu naught times the total current passing through the closed path. That is integration over B dot dl is equal to mu naught times of total charge enclosed. If I amount of current flow through that of straight conductor, magnetic field is produced here. So the magnetic flux associated with that of line element, line integral, that will be B dot dl is equal to mu naught times of the charge enclosed. That equation number 1, that from Ampere's circuital law. Then according to Stokes law, the line integral changes to the surface integral grad cross B ds. Here the surface integral is not closed surface, that should be the open surface, that we studied in case of Stokes law. But from definition of current, I is equal to surface integration over J dot ds, where J is the current density. Therefore, from equation 1 and 2, from equation 1 and 2, we get surface integration over grad cross B ds is equal to mu naught into I, or surface integration over grad cross B ds is equal to mu naught in place of I, whereas surface integration over J dot ds, or surface integration over grad cross B ds is equal to surface integration over mu naught J ds. Now from this two integral, for equalization, that term is equal to this term. So grad cross B is equal to mu naught into J. So the curl of that magnetic field is equal to mu naught times of the current density. a very similar equation in electrostatics. As grad cross E is equal to 0. Here the curl of that electric field is 0, but in that of case there will be no curl. Here the curl factor, that is mu naught j, here curl is 0. Curl basically gives the circulation for unit area, the curl of the magnetic field. So, with the help of this video lecture we understand properties of magnetic field. Two property means divergence and curl of magnetic field. So, divergence of magnetic field is 0, that is proof, and the physical significance of the divergence. Next, curl of that magnetic field and its proof. So, with this useful and informative notes, let me wind up the session. Thank you.